So this afternoon I'm going to be talking about MetroHaul, which is a relatively recent project that's just started here in Europe. It's funded by the European Commission and it's part of the 5GPP funding program. So what is MetroHaul? Essentially, it's looking to develop next generation architecture, management, orchestration of infrastructure that will provide connection services for 5G applications and services. So that's a lot of varying types of network infrastructure. So right at the radio access network, supporting potentially 2.5G, 3G, 4G, and 5G services. So all of the legacy technology right up to sort of current art and beyond. The radio access network, which will predominantly be sort of packet and packet over optical based. The front haul network, which is high variable bit rate optical technology with potential network function. So we're going to have data center like capability where we can instantiate function on general compute hardware. Then there's the backhaul connectivity to packet gateways, particular application services, maybe larger data center resources with cloud applications, and then, of course, gateways out to the internet. So a wide range, spectrum of access, front haul, back haul, and core technologies with management and orchestration platforms sitting above. So clearly, for this type of project in this scope of work, we need a lot of partners. So we have 20 partners from a variety of perspectives. These are the use case developers, network operators, of course, European operators. This is a European project. We have software engineering companies that are going to be developing some of the orchestration and management platform. We've got the academic universities for defining the research space and helping develop some of the new technologies that we're going to be using. And then specific SMEs bringing tailored knowledge for maybe security, scalability, standards, and some deployment support as well. So I mentioned already, actually, this is a broad spectrum of requirements. The problem space is rather large. We will be able to constrain the MetroHaul problem space by identifying sort of key use cases initially. These use cases will generate requirements. Those requirements can then be used to identify particular enabling technologies across the hardware and software stack and the various layers and technology domains that I kind of outlined a couple of minutes ago. The initial use case kind of centers around smart cities. We have 2 smart cities in the UK, for instance, that are both being used to help develop requirements and use cases for the MetroHaul project. One is Bio, which is Bristol is Open, and the other is MK Smart, so it's the Milton Keynes Smart City. We also have European partners who also have smart city infrastructure that would be connected and used to generate requirements and help identify capabilities that are needed and can be delivered across the MetroHaul network. The second use case that we're also actively working on at the moment is crowdsourced video streaming. So we may have large numbers of users connecting to some radio access network. There's a high bitrate requirement for 4K content, maybe 50, 60 frames per second as well, and being able to aggregate that and cache it on CDN nodes, but then maybe be able to do some sort of real-time production development of that video and then distribute the video to a much larger range of consumers. So what are some of the central tenets of the MetroHaul sort of requirements gathering? Well, latency. There is an ongoing discussion at the moment around sort of ultra low latency. There's a particular set of people who might be quite cynical about the need for ultra low latency networking. If indeed you need sort of sub 10 millisecond in the order of 1 to 2 millisecond response times, then maybe you just need to re-architect your networks and actually move kind of function and capability closer to the user. Or you can look to backhaul or indeed front haul and then backhaul particular traffic to sites where you can perform some kind of function. But regardless of sort of if you solve the network latency by re-architecting your network, changing the way that you deploy, function, or use sort of optical technologies and try to keep connections all optical where possible, clearly there's going to be consumers of these sort of different methods for solving the low latency requirement. Capacity, both at the radio access network and also optical, is going to be key for MetroHaul. I mentioned already variable bit rate optical technology, so this is kind of sliceable bandwidth that won't be fixed grid ITU connectivity, but essentially hundreds of megabits, potentially gigabits, tens of gigabits, all the way up to potentially 400 gigabits per second. And then regardless of the access technology and the transport technology, we're going to need control planes. Those might be distributed or a combination of distributed and centralized. We're going to need management capabilities, OAM. We're going to need to secure these networks, and we need to manage end-to-end connections, and not just kind of point-to-point connections, but essentially we may also need network slices, which might be multi-point and multi-tenant connections with function as well. While we're here, we're going to be re-architecting the radio network. While we're at it, clearly we've got a lot of money to spend. We need to kind of think big. As Cliff mentioned earlier, it's not if SDN and NFE is going to be deployed or used in the network. It's an absolute at this point. Some operators are clearly further ahead than others. Within MetroHaul, our focus will be on mostly sort of radio access network virtualization, but depending on the use cases, again, we'll see sort of fixed network function that might typically be proprietary based move into a virtualized platform. There are a lot of research opportunities for the universities involved with MetroHaul. Again, we are looking at short-term opportunities. A lot of the European research funding has requirements for impact. The impact isn't necessarily citations or journals or patents, but it's commercialization of technology as well. It's maybe joint ventures, spin-outs, licensing of technology, contributions to specification and standards organizations. There's going to be techno-economic analysis that's going to be required. Clearly, there's a lot of theoretical, sort of pure research potentially that's available, but we have to be mindful that there are commercial applicabilities as well. So the universities involved in the project will be mindful of that. And so we're going to be working on a few areas, myself included, at British Telecom, but right now we're focusing on scoping the problem space and the use cases, documenting the requirements that will lead into technology selection. We might have to take some of the, for instance, open optical equipment like the OCP project, Open ROADM, maybe TIP, the Voyager box from, for instance, one of the Facebook projects. Maybe we can use that, but there's potentially going to be some development, so it's going to be up to us to try to identify where the gaps are and then how to address those gaps. And maybe we can't evolve one of the existing products, maybe we need to build something new. There is another potential opportunity for service definitions and templates. We're seeing with the 5GPP documentation the need to be able to classify a particular type of service, especially when you're looking to slice up network capability, so bandwidth, provide connection points, topology, but also network function as well. And depending on the type of application, if it's machine-to-machine / IoT, IoE, or extreme broadband, or ultra-low latency for things like augmented reality or virtual reality, there's going to be specific requirements for bandwidth, network connectivity type, latency, and those and various permutations, and those might be expressed as a template that's fed into some kind of orchestrator that can then be analyzed. So we have sort of an intent to policy mappings in order to kind of deploy that through a set of automated interfaces across those multiple technology technology domains. So that's one of an example there of the kind of the template approach. SDN and NFV potentially, not just potentially, but will have a significant impact on the MetroHaul project. But these are ubiquitous terms now. We know that centralized control, especially with the sort of global view of network resources, maybe through a hierarchical model, is a pragmatic approach to network operational network deployment and operation. We know that NFV is clearly a technology that's going to be required for instantiating and different functions in a variety of different places in the network, and then being able to scale up or down or in and out depending on the type of function will firmly sit under sort of the ETSI NFV requirements. Network slicing, hot topic at the moment. We have a set of views for network slicing, but you can look at different documents, go to different organizations, and network slicing will mean something different to each of the individuals from each of those organizations. I guess what I'm saying is it's subjective. From MetroHaul's perspective, we try to categorize network slicing in terms of the resource, so network and function, the need to isolate the connection, so statistical multiplexing isn't the only technology that we might want to use. If we're deploying a network slice, we might actually have to have a sort of true fixed amount of bandwidth with upper and maybe or a minimum and upper bounds, and absolutely isolation security is going to be key as well. And of course that needs to be controlled and orchestrated through a set of well-defined interfaces. There are a variety of potential frameworks that we could apply in order to solve the MetroHaul orchestration and control problem space and requirements, one of which is a relatively recent innovation in the IETF called abstraction of control and transport networks. I won't bore you with an explanation of the various acronyms, but it seems to be a pragmatic approach to network control, where you have a customer network controller, which could be department or application specific, which talks into a multi-domain service controller, which in essence is your supercontroller or your orchestrator. Although I did just say I wasn't going to explain that, but I can't help it. I like acronyms. And then I'll just finish the story then. The PNCs are the physical network controllers responsible for specific domains. It may be a transport domain, a technology domain, maybe packet optical based, but typically traffic engineered, so deterministic. I already mentioned OCP and TIP, potential platforms that will enable some of the optical connectivity. So we're very focused on using open source hardware, open interfaces, especially for the optical transport. The MetroHaul architecture is very much work in process. If anyone was paying attention at the start of the presentation, the project kicked off in June, so this is just kind of the first very high-level view of the MetroHaul architecture. We will expect the architecture to significantly evolve and change over time. Okay, I will move on to just a quick minute on specification and standardization. There's a lot of recent discussion that maybe formal standards are no longer necessary. Code is king. It's the coin of the realm. Implement, you fail fast. Agree through de facto standards, open source code. Well, yeah, that's fine for certain types of applications, but when you're dealing with a high bit rate optical network where you've got multiple vendors involved, both software and hardware, interoperability becomes key. So there's going to be a need for standardization effort, reusing what already exists, whether it's northbound interfaces, southbound interfaces, resource models, Yang-based optical models for things like wavelength selective optical networking or FlexGrid network technology. But there's certainly a number of gaps that exist here as well. Okay, thank you very much. Any questions?